Today we are learning about inductive reasoning. So inductive reasoning is patterns. So we're going to finish patterns. First one, Monday, Wednesday, Friday. So we are skipping days. So we go Friday, skip a day, and then we'd have Sunday. Next one, 3, 6, 9, 12, 15. We're adding 3 to each. So that's 18. Next one, up, and we look facing left and then down. So we are rotating 90 degrees counterclockwise. Which means that the next one would be a triangle facing to the right. Next example, facing to the left, facing halfway between left and up, and we're facing straight up. So we're rotating 45 degrees clockwise. So our next one would be at diagonal up to the right. So each of these, we're adding the next item in to our pattern. What we did was make a conjecture of what would happen next. So a conjecture is a statement you believe to be true based on a pattern or based on inductive reasoning. When you make a conjecture, you need to test several things. If fractions are possible, you need to test them. If positive numbers are possible, you need to test them. If negative numbers are possible, you need to test them. If 0 is possible, you need to test them. So on our first one here, we need to complete our conjecture. The product of an even number and an odd number. So an even number, 2, 4, 6, 8. An odd number, 1, 3, 5, 7. And the product means to multiply. So we're multiplying numbers, an even number and an odd number. So an even number, 2, times an odd number, 3. That gets us 6. And then we need to check for positive and negatives. So an even 2 with a negative 3 gets us negative 6. A negative 2 with an even 3, or with a negative 2 with a positive 3, gets us a negative 6. And a negative 2 with a negative 3 gets us a positive 6. Yes, you can check other numbers besides just 2 and 3. It was just the convenient numbers for me. So, tell me about all of these answers. They are all even. Next up, the number of lines formed by 4 points, no 3 of which are collinear. So we have 4 points over here already for us. No 3 are on the same line. So we need to connect them. We've got a line going through the top 2, a line going through the bottom 2, one on the left, one on the right. Is that all the lines I can draw? No, it's not. I can go diagonal, both from the top left to the bottom right, and bottom left to bottom right. So how many lines is that? Yeah, 6 lines. Next one, the product of 2 odd numbers is what? So product means we're multiplying, and we need 2 odd numbers. So 3 and 5 is 15. Then we need to check negatives. So -7 and +9 is a -63. A -5 and a -9 is +45. What can you tell me about those numbers? They are all odd. In order to show that a conjecture is always true, you have to prove it. So what we did here with our math and drawing the lines, that's proving that our conjecture is true. A counterexample. So counterexample is an example used to prove that a conjecture is false. A counterexample can be a word, can be a phrase, it can be a picture, it can be a number. It all depends on what you are dealing with. So it's something that proves that that statement is false. And it only has to be false one time for it to be false. Our next examples, we want to show that the conjecture is false, so it's already telling us that it's false, and find a counter example. Our first one, for any 3 points in a plane. So this has to happen. We need 3 points on a plane. There are 3 different lines that contain 2 of these points. So we don't want 3 different lines that contain 2 of these points. So in other words, we want to prove that we don't have that. What else could we have? So draw your plane, put 2 points on it, and connect them. Where can that 3rd point go and not make a triangle? It can go right on that line. So if you're in class and doing this on paper, you can draw your picture and be good. If not, what's it called when those 3 points are on the same line? Collinear. So we have collinear points. That's our counterexample. Our next one, supplementary angles are adjacent. So on this one, we need supplementary angles, but we don't want them to be adjacent. Remember, supplementary angles are angles that add up to 180 degrees, and adjacent angles are next to each other. So we want 2 angles that add up to 180 degrees, but we don't want them to be next to each other. So this one, a picture, is a lot easier. You two can do 2 90-degree angles that are not touching each other. If you're typing it on a computer, say 2 right angles that don't touch. Our next one, the temperature in Abilene, Texas never exceeds 100 degrees Fahrenheit in the spring months. So we need 100 degrees Fahrenheit, but not in spring. So which months are spring? March, April, and May. Do we have a month where it exceeds? Yeah. May is 107 degrees. That's our counterexample. Okay, next up, we are going to talk about conditional statements. So these are if-then sentences. So we've got multiple parts of a conditional statement. Our first part is the hypothesis. Now this is not like science class. I don't mean an educated guess. I just mean that it's the first part of your hypothesis and it follows the word if. Okay, your hypothesis always follows the word if. It may be at the beginning of your sentence or it may be in the middle of your sentence, but your hypothesis always follows the word if. The second part is the conclusion. And the conclusion follows the word then. But I can't say that it always follows the word then. It only follows the word then when the hypothesis is at the beginning. Meaning you have if, your hypothesis, you have the word then you have your conclusion. If your hypothesis is at the end of your sentence, that means your conclusion is at the beginning. So our symbols. P is for hypothesis. Q is for conclusion. The arrow in between means then. When we have a Venn diagram, the smallest circle is your hypothesis. Your larger circle is your conclusion. The square or rectangle that's surrounding those circles is everything else. That's related to what we're talking about. Our next example, we want to identify the hypothesis and conclusion of each conditional. If you are writing this on paper, you can underline the hypothesis once and the conclusion twice. If you are typing it, I will show you what to do as well. So, first off, we need to identify the hypothesis. of if a butterfly has a curved black line on its hind wing, then it is a viceroy. It's a butterfly has a curved black line on its hind wing. Now notice that I did not include the word if. If is not part of the hypothesis. It's part of the conditional statement, but not part of the hypothesis. Then we need to identify the conclusion and underline it twice. And that is, it is a viceroy. Notice, again, I did not include then. Then is part of the conditional statement. It is not part of the conclusion. So if you are typing this, you need to either type an H and a colon for hypothesis, or type out the word hypothesis and then put a colon, and then say butterfly has a curved black line on its hind wing. And then you need a C or and a colon, or to write out the whole word conclusion and a colon, and say it is a viceroy. So our next one, a number is divisible by 3 if it is divisible by 6. So this first one, or this next one, what's our hypothesis? It is divisible by 6. And what's our conclusion? A number is divisible by 3. Notice I did not include the word if. So again, if you're typing this, put an H for hypothesis, and say it is divisible by 6. Put a C for conclusion, and yet number is divisible by 3. The next one, we want to write a conditional statement from each of the following. When you are writing your conditional statement, I need you to figure out what you're talking about. What is your noun? That needs to go in your hypothesis. And if there's anything specific to that noun, it goes in your hypothesis. If you figure something out about it, that goes in your conclusion. So what I mean, our first example, 2 angles that are complementary are acute. What are we talking about? We're talking about angles. Angles is my noun. And we have an adjective, 2. And we have something else with it. They are complementary. So that all is going in our hypothesis. The rest of it, they're cute, is our conclusion. So to write this, if 2 angles are complementary, comma, then they are acute. Okay. And our next one, we have a Venn diagram. Remember that the smaller circle, or oval in this case, is our hypothesis, and the larger oval is our conclusion. Then we need to figure out what in general we're talking about. So we have tarantulas and spiders. And I know somebody's saying arachnids. Please don't ask me to spell that word. They aren't actually insects because of the number of legs they have. So we're going to call them animals. We're generally talking about animals on this one. So when we're doing a Venn diagram and having to write a conditional statement, we start with the most general. So if an animal then we go to our hypothesis is a tarantula. And then we go to our conclusion. Make sure I'm spelling right. Then it is a spider. Make sure that you have a capital letter at the beginning. In this case, it's a capital I. You have a comma in the middle, before then, and a period at the end. Yes, I am looking for these things. Yes, we will be taking off points if those things are not there. It is not a proper conditional statement if you do not have a capital letter at the beginning, a comma before the word then, and a period at the end.